A 20-foot ladder leans against a wall. The bottom of the ladder is 7 feet from the wall at the time t equals 0 and slides away from the wall at the rate of 5 feet per second. Find the velocity of the top of the ladder at the time t equals 0. So first you draw a triangle and 20 feet is the ladder, which is a hypotenuse, and then you label the x and y axes. You know dx over dt is 5 feet per second, so then you multiply that by 2 and add 7 to get x, which equals 17. So then the equation you're going to use for define dy dt is x squared plus y squared equals 20, which is the Pythagorean theorem. And you use the Pythagorean theorem to find y by doing the square root of 20 squared minus 17 squared equals y, which is which equals the square root of 111. So then you take the derivative of the Pythagorean theorem, which is 2x times dx dt plus 2y times dy dt, which equals 0 since 20 is a constant. Then you plug in the values you know, which is 17 equals x, and then 5 for dx dt, and then the square root of 111 for y. And then, so you solve it for dy dt, which equals negative 170 over 2 square root of 111, which is approximately negative 8.068 feet per second.
Cars A and B leave a town at the same time. Car A heads due south at a rate of 80 kilometers per hour, and car B heads due west at a rate of 60 kilometers per hour. How fast is the distance between the cars increasing after 3 hours? So we're going to start out by drawing a picture. Here is town, and we know that car A is moving south, and car B is moving west. So we'll just label that real quick, A and B. And we're trying to find the rate at which the distance between them increases. So we're going to call this C. And we're going to start out by using the Pythagorean theorem, because this is a triangle. So A squared plus B squared equals C squared. And ultimately, we're just going to find the derivative of this equation and plug things in. So the derivative would be 2a dA dt plus 2b dB dt equals 2c dc dt. And we could divide out a 2 on both sides. So what do we know? We know that dA dt is the rate at which A is leaving town. And in the problem, it tells us that it's going 80 kilometers per hour. So dA dt is 80 kilometers per hour. And then dB dt is the rate at which car B is leaving town. So that was 60 kilometers per hour. And then dC dt is what we're trying to find. Now we gotta find what A and B are. So A is gonna be A, B, and C actually. So A is gonna be we're gonna find A by multiplying 3 hours times 80 kilometers per hour. And that gives you 240 kilometers. And then B is gonna be 3 hours times 60 kilometers per hour equals 180 kilometers. And to find C, just plug that into the Pythagorean theorem. So A squared plus B squared equals C squared. 240 squared plus 180 squared equals, we'll take the square root of that too. And C is going to end up being 300. Okay, so now we know A, B, and C, and we know dA and dA, dt, and dB, dt. We can just plug it into this equation right here and solve for dC, dt. So we have A, which is 240, times dA, dt, which is 80, plus B, which is 180, times dB, dt, which is 60, equals C, which is 300, times dC, dt. And we're going to solve for dC, dt. And that's going to get us it's going to get us 100 kilometers per hour.
So, a cylinder tank with a radius of 6 meters is filling with fluid at a rate of 108 pi meters cubed per second. How fast is the height increasing? So, you're given R is 6, and dV over dt is 108 meters cubed per second. And then you're trying to find dH over dt. To do this, you use the volume of a cylinder formula, which is pi r squared times height. The derivative is dV over dt equals pi r squared times dH over dt. Then you plug in what you know, so you 108 pi equals 36 pi, since 36 is r is 6 squared, times dH dt. Then you solve dH dt by doing 108 pi over 36 pi and that simplifies down to that simplifies to 3 meters per second equals dH over dt.
So now let's try a cone problem. An underground conical tank standing on its vertex is being filled with water at a rate of 18 pi cubic feet per minute. If the tank has a height of 30 feet and a radius of 15 feet, how fast is the water level rising when the water is 12 feet deep? So here I've already drawn this cone standing on its vertex, and I've labeled it with its height, which is 30 feet, and its radius, which is 15 feet. And we're trying to find out the rate that the water rises when the water is 12 feet deep. as shown here. So first, we want to know the equation of the volume of a cone. And that is going to be V equals 1/3 pi r squared times h. So we're trying to find the rate of which the height of the water rises. So that is going to be dH dt is ultimately what we're going after. So we want to get rid of the r and have it all in terms of h, so we don't have two unknown variables. So to do that, since they tell us that h equals 30 feet and r equals 15, it's almost like proportional to each other. So we can just cross multiply and find that 30r equals 15h. And then solving for r equals 15 over 30, so 0.5h, which is h over 2. So using this, we can sub this into the r and rewrite the equation as v equals 1/3 pi h over 2 squared times h. And ultimately, we can also simplify this into v equals, this is h squared times h is h cubed over 2 squared is 4 times 3 is 12 times pi. So that's our simplified version. So now we just want to find the derivative of this. So I'm going to just write down here, dv dt. We're differentiating in respect to t. So dv dt equals, find the derivative of this. So you know that pi over 12 is a constant, so we can pull that out, and then derivative of h cubed is 3h squared, and then dh dt. So we know that dv dt, we know what it is because it was stated in the problem. It's being filled at a rate of 18 pi feet cubed per minute. So dv dt equals 18 pi, as stated in the problem. And we also have to know h. So that is going to be 12, also stated in the problem. So we know it's this. So basically we could just plug stuff in now. So dv dt 18 pi equals pi over 12 times 3 times 12 squared dh dt, and just solve for dh dt. So ultimately we are going to end up with dh dt equals 1/2 feet per minute. And that is the final answer to this problem.